And back to this message. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, so today we're going to go on. Oops, let's go back down here. Sorry, other class. We're going to go on and cover section 6.2. But first, I had some requests from you to do some questions from problem 6.1. So let's get to a blank screen here. And let's see here. So here's some web-assigned questions. We're going to start by taking a look at number 17. And as I looked at this, I was reminded, I think this is my fault in terms of clarifying the directions. The directions say, factor the polynomial by factoring out the opposite of the GCF. Okay, the greatest common factor. What the author of the textbook does, they consider a greatest common factor to always be positive. So when they say factor out the opposite, they're saying take out a negative. I don't tend to focus on that. I just tend to say, well, they're both the GCF. But again, we'll go with what the author's doing here. So what they're saying is find the greatest common factor, take the opposite of it out. Now, this student took out the greatest common factor, but it says factor it. It doesn't say identify the greatest common factor. So let me clarify that here. Let's see here. Let me write that on my other screen. And then we'll take a look at that. So the directions say factor the polynomial by factoring out the opposite of the GCF. Okay, well, the GCF would be 5a. So the opposite of that would be negative 5a. So we're going to take out a negative 5a, and then what's left over? 4a minus 3. So hopefully that clarifies what they were asking there. Any questions about that particular problem? Okay, we're going to take a look at 18 from that same web assign. The directions are exactly the same. And it says negative 45a to the 5th minus 75a to the 4th plus 15a cubed. Well, the greatest common factor, so the greatest common factor would be 15a cubed. So if we factor the opposite out, we take out negative 15a cubed. But we're not just identifying the GCF or the opposite of it, we're factoring it out, so we've got to have everything still there. So what's left here would be 3a squared plus 5a minus 1. So that would be the answer for that particular problem. Any questions there? All right. And then we're going to take a look at problem number 33 from that same assignment. Again, your problems, somebody asked in the other class, what are, in WebAssign, there's numbers that are red. Everybody has the same kinds of problems, but the red numbers are different from one person to another. So for instance, the 33 I'm going to do now for this person might look different from the one that you have. It'll be the same type of problem, but perhaps different numbers. The directions here just say factor 6a squared b plus 18a squared minus 12ab minus 36a. Okay, now we have 4 terms. There is a greatest common factor of the whole thing, and that would be 6a. So taking out 6a, I get ab plus 3a minus 2b minus 6. Okay. Now, this is in fact what the student that asked about this had as their answer. So why is it incorrect? Well, we're not done yet, because we can take what's inside and use factoring by grouping. The greatest common factor here is an a with a b plus 3 left over. So I have to have a b plus 3 over here, take out a minus 2. So my final answer is 6a times b plus 3 times a minus 2. And there you have it. Any questions about that? Okay, I'm going to go back and look at another person's request. Let's see here. Number 11. Okay. I'll show you what this one is. So number 11, it says, find the greatest common factor of the list of terms. Now, the last problems, it said, factor out the greatest common factor. That means that you still have the whole thing there. This is just saying, find the GCF, okay? And I suspect that that's, yeah, I can see what the student had. And basically it was the directions that threw them off. Also, these are two separate expressions. They aren't being added together or anything. So it's not like we could factor the whole thing. Well, the greatest common factor is b plus c. Okay with that? Any questions there? All right, and somebody else asked that same question, but I suspect that it's going to be very similar. So the confusion perhaps is in the questions. If it says find the greatest common factor, you just identify that piece. If it says factor out the greatest common factor, you would have that greatest common factor times whatever's left. If it says factor out the opposite, you'd have negative times the greatest common factor times whatever's left, okay? So again, I think it was more a misunderstanding of the directions than students not really knowing how to do the process. All right, anything else before we go on to the new section? All righty.
Could you go over number 27?
Ah, okay. Can you tell me what it is?
I'm not sure.
Sorry, if you'd caught me before I closed everything up.
Oh, sorry.
It's all right. I mean, I can find a number 27 if you really want, but can you find it, or do you want me to look at it to get it?
I'm looking.
Okay. We pause briefly for station identification. Let's see here. I'm going to race and see if I can get there faster. Okay, let's see.
Yeah, it's not letting me get in unless I leave the chat.
That's okay. I'm going there. So this is 6.1, number 11,
Number 27.
27, sorry, yeah, 27. Okay, so the factor by grouping 4t cubed plus 40 plus 20t squared plus 8t, that one?
Yeah.
Okay, 4t cubed plus 40 plus 20t squared plus 8t. Okay, so right off the bat, I can tell you that I'm going to put things in standard form. So I'm going to rewrite this 4t cubed plus 20t squared plus 8t plus 40. You see that?
Yes.
Then I'm going to take out a greatest common factor, which is a 4. So then what do I have left? I have t cubed plus 5t squared plus 2t plus 10. But then I'm going to use factoring by grouping. So I'm going to have 4, and then here I'm going to have t squared times t plus 5. So over here I'll have t plus 5, and I'm going to take out a plus 2. So I've got 4 times t plus 5 times t squared plus 2. Paula, you okay with that?
Yes, thank you.
Any questions about what I did there, you or anybody else there?
No.
Okay. Any other questions people want me to look at before we go on to 6.2? Alrighty, and let's go on. So what I want to do actually to start with is I want to go back to section 5. I can't remember if it's 5.5 or 6 or whatever, but and you don't literally have to do that, but this is where this topic came up, where we FOIL binomials together. So let's say we've got something like x plus 3 times x minus 2, and it says multiply or get the product or FOIL. Okay, so we take x times x and we get x squared, x times minus 2 and we get minus 2x, 3 times x and we get plus 3x, 3 times minus 2 and we get minus 6. Everybody okay with that process, what I'm doing there?
Yes.
All right, then combining like terms, I get x squared plus x minus 6. So I multiply two binomials together and I get a trinomial with 3 terms. Now, back in chapter 5, we were multiplying and dividing polynomials. In this chapter, we're going to be unmultiplying, so to speak. Or instead of distributing like we're doing here, we're going to be undistributing, but we're going to call it factoring. So rather than taking x plus 3 times x minus 2 and getting x squared plus x minus 6, we're going to start with x squared plus x minus 6, and we're going to go backwards. Okay, so we're going to kind of undo the trinomial. Well, let me do this. I'm going to recopy that now that I've got all that mess there. And I had x squared minus 2x plus 3x minus 6, x squared plus x minus 6. Okay. So what we want to do is we want to take this and end up with that. And obviously we've got the answer right in front of us for this problem, but that's not always going to be the case. So I want to look at the mechanics of how we get from here to here so that we can undo that. Okay. This term came from the first times the first. In fact, FOIL stands for first, outer, inner, last. So this comes from the, that is the first times the first, okay? This comes from the last times the last, so that's the ol. So the comes from there and the ol comes from there in FOIL, all right? Where does this come from? Well, that comes from the two middle terms. Anybody here a British or an Australian soccer player, they like to say, oi, mate. So the OI. So this is the O and this is the oi. I know this is pretty sad, but so my point is this. If I'm going to take x squared plus x minus 6, and I'm going to break it apart into factors, this goes into the first part of each binomial. So that's going to get split up that way. The minus 6 goes there and there. But now I've got a problem because, well, let's see. 3 times negative 2 is negative 6. But 1 times negative 6 is also negative 6. Or negative 1 times 6 is also negative 6. So there's not knowing the answer, not having that ahead of time, I'm not sure what these two numbers are going to be. I need two numbers whose product, P standing for product, is negative 6. Okay. But there's another thing I have to consider. Where does this come from? That middle term comes from this product plus that product. So the inner and the outer, or the OI. So I need a sum that's equal to 1 because there's 1x. So I'm looking for a product that's negative 6 and a sum that's positive 1. Well, what two numbers have a product of negative 6? Let's see, negative 6 and 1, negative 1 and 6, negative 3 and 2, 3 and negative, 3 and negative 2, that's the only pair of numbers whose product is negative 6, but whose sum is positive 1. So I'm going to get a plus 3 and a minus 2. So x plus 3, x minus 2, and there's my answer of having factored that trinomial. And I know this is a big mess. The next problem won't be quite so messy, but the key is that we're looking for a product that's equal to that number and a sum that's equal to this number's coefficient. All right, let's see if we can put this together here. Okay. So let's say we've got y squared plus 4y plus 3. And we want to factor it. We want to pull it apart as the product of two factors. And in this case, each of those factors is going to be a binomial, two terms. All right. Since the leading term is 1y squared, we're going to put a y here and a y there. Okay. Now, the 3 is what has to be formed by the product. So the product of these two numbers that go right here and right here has to be 3, and the sum has to be 4. Are you following what I'm doing here?
Yes.
At least you are. Okay. Maybe everybody else has gone asleep. Okay. All right. So the product is 3 and the sum is 4. Well, let's see. 3 times 1 is a product of 3. Oh, and 3 plus 1 is 4. So y plus 3, y plus 1. Let's check our work. How would we check our work? We're going to FOIL that back together to see if we get this. So y times y is y squared plus 1y plus 3y plus 3, y squared plus 4y plus 3. So it checks. So this is our answer. We've taken the trinomial and we've factored it into y plus 3 times y plus 1. All righty. Let's take a look at another example. N squared minus 7n plus 10. I also want to point out that this trinomial is in standard form, or descending powers of the variable, in squared, n to the first power, and no n at all. Okay. I also want to point out there's no greatest common factor that I could take out. First, that is. So now I've got an n and an n. My product of the two numbers left is going to be a positive 10, but my sum of those two numbers has to be a negative 7. So here's the product and here's the sum. Now, what pair of numbers give me a product of 10? Well, 10 and 1, 5 and 2. Neither one of those are going to give me a sum that's negative. Oh, but wait a minute. Also, negative 10 and negative 1 give me a product of 10, and negative 5 and negative 2 give me a product of 10. So if my product is positive, it's got to be two positive numbers or two negative numbers. But if I take two positive numbers and add them, I'm never going to get a negative sum, or am I? So if it's a positive product and a negative sum, it's got to be two negative numbers, and there they are. Did you see how I went through that by looking at the signs? If the product is positive, the numbers have to have the same sign. If the sum is positive, they'd both be positive. If the sum is negative, the numbers would both have to be negative. All right, let's keep going. Let's say I've got u squared plus u minus 42. This is in descending powers of the variable. There's no greatest common factor I can remove first. So I'm going to take that is the first times the first, the u times the u, and put them there. So now I need a product that's negative 42 and a sum that's 1. Recall that there's an implied coefficient of a 1 in front of the u. Well, now we've got a product that's negative. Well, positive times positive is positive, and negative times negative is also positive. So if we're going to get a negative product, we've got to have one of each. One of the numbers has to be positive and one of them has to be negative, okay? But consider this, when we add these two numbers together, their sum is a positive 1. So we've got a positive number and a negative number. When we add them together, we get a positive 1. So that means the positive number is going to dominate. It's going to have a larger absolute value than the negative. How much larger? Just 1. Well, what times what is 42? What comes to mind?
6 and 7.
Right, 6 and 7. Well, what if we had a negative 6 and a positive 7? That would give us a negative 42 product and a positive 1 as a sum. So there's our two numbers. Does that make sense?
Yes.
Maybe. Now, some of you are going to be quicker at this than others. Thank you for that thumbs up. And the reason is because you know your multiplication tables. If you're kind of like, let's see, 42, what times what is 42? And you got to go to your calculator. The person next to you that knows that it's 6 times 7, they're going to get this much quicker. But anyway, let's continue. Let's see here. A squared minus 10a minus 39. This is a trinomial, 3 terms. It's in descending powers of the variable. There's no greatest common factor I can take out. So I'm going to break it down a and a. The product is going to be negative 39 and the sum is going to be negative 10. Is anybody not sure where I got the negative 39 as the product and the negative 10 as the sum? You're okay? All right. So if my product is negative, that means I have to have one of each. I've got to have a positive and a negative, because positive times negative gives you a negative product. But I'm going to add those same two numbers together and get a negative sum. So that means that the negative has to be bigger than the positive. How much bigger? Well, its absolute value has to be 10 greater. Let's see. I could go with negative 39 and 1, or negative 13 and, oh, there it is, negative 13 and 3. The product is negative 39. The sum is negative 10. So minus 13 plus 3. Could I have written it this way instead? A plus 3, A minus 13. Is that the same answer? Yes or no?
Yes,
Why?
because multiplication works no matter what
Speak up a
direction.
little. Sorry, I can't hear you guys. Multiplication what?
Multiplication works like no matter what direction you do it in.
Okay. What's that called? Anybody? What do you call it when you drive back and forth someplace? Back and forth to work, back and forth to school. What do you call that? Going back and forth. Starts with a C.
Commute.
What?
Commute.
Commute. You commute. This is the commute. So multiplication is commutative. We can multiply two factors in either order. Okay, good. Let's see here. Okay, pressing onward. Negative x squared plus 9x minus 20. Now, we have a trinomial. It's in standard form. However, well, there's not really any greatest common factor other than a 1, but the leading coefficient is negative, and it's much easier to factor something when the leading coefficient is positive. So the first thing we're going to do is factor out a negative 1. And I can either put a negative 1 out there or just a negative sign. So I could write it that way, or I could have written it like this. Okay, either way. Now, let's focus on the part that's in the parentheses. I'm going to split up the x and the x. I'm going to have a product that's 20 and a sum that's negative 9. I'm no longer looking at this, right? I've moved on to this. So my product is positive. So I've got to have two positive numbers or two negative numbers, but my sum is negative. Well, I can't add two positive numbers and get a negative sum. So my two numbers are going to have to both be negative. Let's see, negative 20 and negative 1, negative 10 and negative 2, negative 5. Oh, there they are. Now, you don't have to write all the possibilities like I'm doing. If you can see that the answer is negative 5 and negative 4, you can go right there. But I'm just kind of going through the thought process of, well, let's try this, let's try this. But if you can see it, you don't have to go through all those intermediate steps. So there's my answer, or again, I could write it like that. So either one of those. Any questions there? All righty. Let's take a look at another example. A squared plus 6ab plus 5b squared. This, believe it or not, is in standard form in terms of the variable a. We've got a squared, a, no a at all. Now, we could switch everything around and make it in standard form in terms of b, but we'll do that tomorrow. Okay, so there's no greatest common factor, and the leading coefficient is positive. So I'm going to split it up like this. I'm going to have a and a. My product is 5 and my sum is 6. Okay. Well, let's see. To get a positive product, it's got to be positive times positive or negative times negative. Hang on a second here. I'm going to move this so it's straight in front of me so I don't look off to the side the whole time. Okay. But the sum is positive, so both numbers have to be positive. Let's see, how about 5 and 1, or, oh, 5, there it is, 5 and 1, plus 5 plus 1. Now, this isn't the right answer. I'm not done yet. What have I forgotten? what is it that makes honey?
B.
The bees. That's what we've forgotten. This thing. So those bees have to be separated as well so that we get 6AB in the middle. All right. So in fact, let's go back and do this one again. The safer way to go would be to do this. Say, okay, I know I'm going to have A's up front, but I'm going to have B's at the end. And then I go through and I get my two numbers of a 5 and 1. Now, I don't need to put a 1 in front of the B because it's implied. It isn't wrong if you do, though. I'm not sure, but I think WebAssign actually marks it wrong if you put a 1 there. And I would go back and look at it. And I wouldn't mark it wrong, but just to let you know that I don't think they put the 1 in front of the B, like right there kind of thing. Okay. Let's see here. How about this one? M squared plus mn minus 6n squared. It's in standard form in terms of m squared, no m at all, going down. Leading coefficient is positive, so I don't need to factor out a -1, and there's no greatest common factor I can take out. So I'm going to have m's at the front and n's at the end. My product is 1, my sum is -6. Oh, that's backwards, isn't it? I did that wrong. My product is -6 and my sum is 1. That's what I get for thinking ahead too far. I'm always thinking ahead instead of being right here. That's not a good thing. Product -6. Let's see. Well, the sum is positive, so I've got to have a positive and a negative, and the positive's got to be a little bit bigger. So 6 and -1, 3 and, oh, how about that? 3 and -2. Does that work? So +3 minus 2. Well, let's check our work. Let's make sure. There's m squared minus 2mn plus 3mn minus 6n squared, combining like terms, m squared plus mn minus 6n squared. So it checks. You always want to check your work because it's real easy sometimes to get the wrong numbers. It may seem simple, but if it's too simple, sometimes you get the wrong thing. Like I've had people use 6 and -1 and say, well, the bigger number is positive. That gives you the right product, but it doesn't give you the right sum. That would give you a sum of 5. So be careful. Okay. Now, 3y squared minus 21y plus 18. Here we have a trinomial in standard form, but it has a greatest common factor that we can take out, which is a 3. So our first step is going to be to take out that greatest common factor. Now we're going to look at the trinomial that's remaining and see if we can factor it further. Well, the y squared would get split up like that. The product is 6, and the sum is -7. Now, again, I'm not looking at this anymore. I'm looking at this. So here's my product, and here's my sum. How about -6 and -1? That would give you a product of 6 and a sum of -7. So -6 minus 1. All right with that? I guess so. No one's complaining, so I'll move on. Let's see here. -m cubed plus m squared plus 56m. Well, this is in standard form in terms of m. There's a greatest common factor, which is an m. But my leading coefficient is negative, and I'd like it to be positive. So I'm going to take out the opposite of the greatest common factor. I'm going to factor out a -m. Okay? So then I'm going to get m squared minus m minus 56. Be careful there. So far, so good. So now I'm going to get M, product is negative 56, sum is negative 1. What times what is 56? Come on, somebody, what times what? What's the first thing should come to mind? What times what is 56?
8 times 7.
8 times 7, right. So if we have a negative 8 and a positive 7, that's going to give us the product of negative 56 and the sum of negative 1. See how knowing that helps you get there faster? So minus 8 plus 7. If you don't have your multiplication tables memorized because you've depended too much on a calculator, it's not too late. All righty. Let's see here. How are we doing here? R squared minus 9R minus 12. Well, this is a trinomial in standard form in terms of R. There's no greatest common factor to take out, and the leading coefficient is positive. So let's just go from there. We'd have an R and an R. The product would be negative 12, and the sum would be negative 9. So to get a negative product, I've got to have a positive factor and a negative factor. But when I add those two numbers together and make it into a sum, it has to be negative 9. So that means that positive and negative factor, the negative has to be more powerful. So I need a big negative and a small positive, so to speak. Okay. So how about negative 12 and 1? No, that's not going to do it. Negative 6 and 2. That's not going to do it. Negative 3 and 2. That's not going to do it. Well, I could do negative 2 and 3, but didn't we determine that the negative had to be more powerful? So that wouldn't work anyway. Well, none of these work. That's because this is a prime polynomial, or you just say prime. It doesn't factor, okay? Just like the number 17 is a prime number. You can't write it as anything other than 1 times 17. This is a prime polynomial. You can't pull it apart using this method we're trying. So it's prime. Okay. Let's see here. Negative R squared plus 14R minus 45. This is a trinomial in standard form. It doesn't have a greatest common factor, but we could factor out a negative 1 to make that leading coefficient positive. Okay. So now, let's see, we're going to have R and R. Our product is going to be positive 45. Our sum is going to be negative 14. To get a positive product, we need 2 positive factors or 2 negative factors, but the sum is negative, so we've got to have 2 negative numbers. Let's see, negative 45 and negative 1, negative 15 and negative, oh, how about negative 9 and negative 5? And again, I'm writing possibilities. You can go straight to the one that's correct if you can see it ahead of time. Okay, so minus 9, minus 5. And again, you could write it this way, or you could put a 1 there that's implied up here anyway. Okay. Let's see here. How about this? 40c squared minus 12c. The directions here say choose the correct method from section 6.1 or 6.2 to factor each of the following. This isn't a trinomial. This goes back to yesterday's assignment. Let's see, the greatest common factor. I know we can take a c out. We can take a 2 out. We could take a 4 out. I think that's it. Well, let's see. If I take out a 4c, I get 10c minus 3. How do I know if that's correct? Well, if I FOIL it back together, I get 40c squared minus 12c. And looking here, 10c minus 3. There's nothing I can take out of that other than a 1. And taking a 1 out is still going to give me 4c on the outside. So all I can do is take out the greatest common factor for C and times the leftovers in the parentheses. Okay. Now, again, it didn't say identify the least or the greatest common factor. It said factor it. So our final answer should include everything that goes back together to get what we started with. Okay. How about this one? M squared plus 3m minus 20. This is a trinomial in standard form. There's no greatest common factor. The leading coefficient is a 1, so we're good to go. M, product is negative 20, sum is 3. So this process applies to trinomials, not binomials or quadrinomials, four terms, but trinomials. All right, so my product is negative 20, which means I have to have one positive factor and one negative factor. When I add them together, I get a positive 3. So that means my positive has to be bigger than my negative by 3. So big positive, little negative, 20, negative 1, 10, negative 2, 5, negative 4. Conclusion?
It's a prime.
It's prime. Now, be careful. I've had students do this. They'll look at it, determine it's prime, so they'll do nothing thinking that that means it's prime. No, you have to declare it. You have to say it's prime. You can't just leave it blank and say, well, it wasn't factorable. You have to say that it's prime, okay? All right. And the directions in WebAssign will lead you to what you have to do in terms of that. Let's see here. How about this one? 33g to the 4th power minus 99. So this is not a trinomial. So we're not going to use that whole thing we've been looking at. This goes back to yesterday. What's the greatest common factor?
11.
Okay, let's see. 11, this would be what? 3g to the 4th minus 9. Is there something else I could take out from the parentheses?
Yeah. Would
What?
it be 33?
Right, right. So we take out a 33. There you go. And that's all we can do with that. All right. So for tonight, you've got section 6.2 to do. I will be back. I can't talk worth a darn. I'll be back at 1:15 office hour. So if you have questions and can join me then, if you have questions and can't join me, then email me and I'll try to get back to you when I can. And I can always do problems tomorrow during class if you have questions as well. All righty. So with that, I will stop the recording.